Alright, 12.2, power rules for exponents. Okay, let's continue on. Use the power rule for exponents to simplify expressions. Use the rule for a power of product to simplify expressions. And we're going to use the power of quotients to simplify expressions. And use combination rules for exponents to simplify expressions. Let's remember some of the rules for exponents that you've been learning here. And notice these are all the ones we just did in the last section. Just kind of look over those real quick. Yeah. Same rules apply. Let's go ahead and go into our new rule that we're learning today. Power rule for exponents. If a is a non-zero real number and m and n are integers, then, okay, notice when you have a power and it's contained inside of a parenthesis and it's raised to a power, you just multiply the powers, as long as you got the same base, okay? But also we're going to be distributing powers eventually, okay? So let's kind of be warned of that, okay? Then, and really honestly, it doesn't even matter if it's the same base in here, okay, because you're still going to distribute powers, but when you have the same base, multiply the powers. Okay, so looking at our first example here, okay, we have x squared in parentheses and all of that raised to the power of 4. So let's come in here, let me grab my pen, and notice that that's going to be the same thing as saying x 2 times 4, which is just going to give me x to the power of 8. Okay, same thing applies here. Let's just kind of keep going with the rule. Don't overthink it, okay? You're going to have x 5 times negative 2, okay? Well, notice we got a positive and negative. That's going to give us a negative, okay? And 5 times 2 is 10, so we're going to have x to the negative 10. But remembering our negative exponent rules, that means that we're going to end up having 1x to the 10 on the bottom. Okay, and same thing here. Doesn't matter where that negative shows up, we still have a negative. So we got a y here, negative 7 times 2. Well, that's going to be the same thing as saying y to the negative 14, because I got a positive and a negative. That creates a negative. 7 times 2 is 14. So that's going to create a 1 over y to the 14. And let's do one last one here. Same thing. Okay, so we've got 2, well, notice we've got a 3 here, and then we've got this negative 2, okay, well, that's going to give us 2, keep the 2 here, well, 3 times 2 is going to be 6, I got a positive and a negative, that's going to give me a negative 6, okay, well, that's going to also, notice, I can remove this and put it down on the bottom, that means I can have 1 over 2 to the 6th, and 2 to the power of 6 is going to give us 64. So we got 1 over 64. Pretty straightforward on those, which makes them, makes them pretty, you should be pretty well versed at doing this by now, but, it's just going to take some practice, take some time, and you're going to be able to click it out. Okay, rule for power of product. Okay, if a and b are non-zero real numbers and n is an integer, then a times b to all raised to the power of n is, notice, we're just distributing that power to everything inside there. That's all that's going to happen. That's kind of what I hinted at whenever we were first looking at this. So let's just do some examples here. Okay, simplify each expression by using the power rules of exponents. Okay, so the first one here, we have 5x all raised to the power of 1. Okay, sorry, 5x raised to the power of 2. Very sorry. Let's continue on here and notice that that's going to be the same thing as 5x, and I want to kind of write it like this. I take this power of 2, and I'm going to distribute that guy to there and to here, because I notice that I am having 5 multiplied by x. Well, that's going to be the same thing as saying 5 squared multiplied by x squared, and if we continue on with that, 5 squared is going to be 25, and then the x squared, just keep that as the same. And that would be our final answer there. Okay. Continuing on, notice we have x, y, all raised to the power of 3. Kind of write this down just a little bit. Well, whenever I take this, I'll rewrite it like I did before. Take this power of 3, and you're basically distributing it, okay? And then you come in here, multiply that, make sure that those are multiplication happening, okay? There'll be rules later that we'll have to change some of this, but if you have multiplication or division happening, no problem. So we got x to the power of 3 and then y to the power of 3. Well, That's as far as I can go with this, because as you can tell, I don't know what x and y are. So this is a simplified form. Okay, let's continue on. Okay, in the expression such as negative x squared, we know that negative 1 is understood to be the coefficient of x squared. That is, negative x squared equals 1 times x squared. The same is true for expressions with numbers such as negative 7 squared. Okay, the reason they're saying this is because of this right here. If you're not careful, what they're saying is, normally you would think, okay, x squared is x times x, and that's going to be a positive, okay? But that's not what's going to happen here. Notice, you're still going to get a negative number here, okay? Which is why you're getting this negative 49. It's because of this negative 1. If you think back to your PEMDAS rules, okay, you do exponents and then you do multiplication. Well, that's why this ends up being negative. If you want this guy to end up being positive, you're going to have to put him in parentheses, okay? Then that 2 will get distributed to everything in there, including this negative 1 here. Okay, so that's how that guy would end up becoming positive. So I'll show that more as we go along. Okay, just another way how they did it here. See, this is how they're kind of showing it here. So, okay, let's do the quotient. Okay, if a and b are non-zero real numbers and n is an integer, then same thing. Just take this in and just make sure to distribute it to the numerator and the denominator, and then you can take the powers if you need to, and then you can also simplify if you need to, which you're going to see that happen a lot. So let's come in here and let's do some examples. Okay, we've got simplify each expression by using the rules for the power of a quotient. Well, notice this first one. Like I said, we can just take this guy and just put it in both places, which is going to be the same thing as saying x to the power of 5 all over x to the power of 5. Okay. And then let's look at this next one here. Well, that 4 is going to get distributed to there and then also to there. So this is going to be the same thing as saying 2 to the power of 4 all over a to the power of 4. Okay. And 2 to the power of 4 is going to give us, sorry, hold on one second. 2 to the power of 4 is going to give us 16. And then you're just going to have this a to the power of 4 here. All right, example 4, let's simplify each expression using the appropriate rules for exponents. Okay, notice this first one here. We've got negative 2x all over y squared, all of that raised to the power of 3. So whenever we start working on this, let's go ahead and start distributing this power. Okay, we're going to bring this guy here. Okay, I'm going to bring him here, and I'm also going to bring him here. Okay, well, if we rewrite this, it's going to look like this: negative 2 to the power of 3, x to the power of 3, and then notice here on the bottom we have a y 2 times 3. Well, if we start evaluating this, notice this negative 2/3 is going to turn into a negative 8, and we can keep the x cubed, and then here we've got 2 times 3. Okay, so that's going to give us y times 6, and that would be completely done. You're completely done at this point, because notice there's no more simplification that could happen. Okay, let's do another one here. And notice we're going to do this in 2 different methods. Okay, first off, we can simplify by doing the parentheses first. So if we did that, remember, we can come in here and look carefully. Okay, this will turn into 3. Okay, a 2 minus 3, b 1 minus 2, and for right now I'm just going to keep a 1 on the bottom. Okay, well, notice I'm going to keep the 3 there, and then a minus 2 is going to give me a to the negative 1, and then I'll have b to the negative 1 all over 1. Okay, and then let's not forget that all of this needs to be raised to the power of 2. Okay, rewriting once again, I end up having a 3 on top, and then an a and b, and then I can have this power 2 out there that's now going to be distributed to everything. Well, I know 3 squared is going to be 9, and then I'm going to have a squared, and then I'm going to have b squared. That's one way to do it. Let's now look at the other way, method 2. We're going to go ahead and apply the quotient rule first. Okay, so let's come in here where we read our equation here. We've got 3a squared, expression, all over a to the 3rd b squared all raised to the power of 2. Well, notice what I'm going to do is I'm going to take this power of 2 and distribute it to everything in here first, which is going to give me 3 squared, a squared, okay, the a squared times 2, and then b squared, all over, and then I've got this a 3 times 2, and then b 2 times 2. Well, when we simplify this, we're going to get 9 a to the 4th and b squared all over a to the 6th and then b to the 4th. And now we can use our quotient rule, which is going to give us a 9a 4 minus 6 b 2 minus 4. Okay, and for right now, I'll just kind of put a placeholder of 1 over that because I can already tell I'm going to get some negative numbers here. Okay, so then I continue on and I've got 9a to the negative 2, b to the negative 2 all over 1, which, going with our negative exponent rule, gives me 9, okay, a squared and b squared. And so notice either way works out just fine. You can do it however you like, okay? Some problems are going to lend more to method 1. Some problems are going to lend more to method 2. And that's just going to be something you're going to learn from. And if you're like me, because I'm not a math genius, okay, sometimes you do it the hard way forever until it just finally clicks. Okay, come in here, and let's just remember some of these rules that we've been learning. We've kind of added to our rules of properties now, and now we've got all the rules that we're going to need so far to kind of continue on. So